All right, guys, we're going to take the same screws that we just set up for a corrosion test. We're going to take the 14s, the 9-inch 14s, and we're going to take them, pop them in some 22 gauge, I don't know the KSI, steel deck, and we're going to just get a really rough torque back out number from each of them. This is not going to be completely scientific due to this non-complexity of this machine, but it is a good general indicator. All right, I'm going to do something like this so they're not pushing up as I do this. We'll go with ours first here. This is how many pounds of torque it takes to back the screw out. 10, 20. All right, we're at 22 pounds. Holding around 18. We'll try the second one. 10, 20, 30, 32, just holding around 22 pounds. Try competition 1, 10, 10, 10, it's holding around 10 pounds. Competition 1, screw 2. 10, holding around 10 pounds. Competition 2, screw 1. Oof. It's about 8 pounds from the peak. Competition 2, screw 2. Competition 2, screw 2, 10 pounds, started at 10 pounds, it's going down to 8-ish. Competition 3, screw 1, barely any resistance, maybe 6 pounds there, there's some resistance. There's 5 pounds, 5 pounds. Yeah, I could turn this one with my fingers. All right, competition 3, screw 2. There's really no measurable resistance. Okay, these guys, I can't budge. This is 10 threads per inch. In all fairness, these are 13 threads per inch. This is for insulation attachment only. We're going to do some other testing and see. Maybe this thing shines someplace else, but it's not designed for seams to be a seam plate fastener.